Okay, here's our third video from section 2.1 talking about sets. We're going to start by talking about inequality notation with our sets. So we might have seen these notations in the past where we have these little inequality symbols. Some teachers, when you're first learning it, maybe call them alligators, right? Because the alligator wants to eat the bigger number. The most important thing is being able to write this and read this the correct way. So on this first one, this says x is less than whatever that number is. X is less than a. So if I gave you this set builder notation, we would have the set of all x's such that x is an element of the natural numbers and x is less than 4. So the roster method example would then be 1, 2, and 3. We have to be less than 4 and we have to be part of the natural numbers. So starting at 1 and going to 3, x is less than 4. Or we might have this notation, x is less than or equal to a certain number. So if I'm a natural number and I'm less than or equal to 4, then that means I'm 1, 2, 3, and 4 because I want to equal 4 as well. This inequality notation says that x is greater than the number, right? Remember the alligator wants to eat the bigger thing, so because it's eating the x, that means x is greater than that number. So in this example, if I'm a natural number and x is greater than 4, well, I need to be greater than 4, so that means 5, 6, 7, and so on. We can do our 3 numbers and then our little dot, 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 right? Our little ellipses. Or I can be x is greater than or equal to that number, including 4, and then going up from there. We might also have more of a compound inequality situation, something that looks like this, where this says x is greater than a, but less than b. So in this example, if I'm a natural number, and I want x to be greater than 4, but less than 8. Well, what numbers are greater than 4 and less than 8? Well, that includes the numbers 5, 6, and 7. So that would be my set in roster method. Or I might be greater than or equal to 4, but less than or equal to 8. So then I'm going to start at 4 and include 4, 5, 6, 7, and I'm going to include 8 in my set. I could be greater than or equal to 4, but just less than 8. Or I could be greater than 4, but less than or equal to 8. So being very careful to look at the symbol to let me know what numbers are included in my set. Let's practice a few. Looking at example number 7, it says express each of the following sets using roster method. Remember, roster method is listing them out. The first one says the set of all x's such that x is an element in the natural numbers. Remember, natural numbers are 1 and up, where x is, if you read that carefully, what does that say? X is less than or equal to 100. So how do you think you would write this in roster method if you're a natural number and you have to be less than or equal to 100? Maybe you wrote it like this. You started at 100 because we can be equal to, but then we have to be less than. So 100, 99, 98, and then maybe your dot, 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 and then all the way, to 1. So if you stopped and you just said 100, 99, 98, dot, 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 that would actually be an incorrect answer. Because remember, if we have to be in the natural numbers, we have to stop at 1. So that's where my little 1 comes in. If I were to do just the dot, 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 then wouldn't that mean I can go all the way down into negative numbers, which is really not a natural number. So you have to make sure that you started at 100 and you have to make sure that you end it at 1 so it doesn't go below. Or, because order doesn't matter, maybe you started at 1, you went 1, 2, 3, dot, 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 but then you stopped it at 100. Either one of these answers would be acceptable for roster method in this example, making sure that you start at 1 and you end at 100, including all of the numbers in between, but nothing outside of that group. Look at example B. It says the set of all x's such that x is an element in the natural numbers, so 1, 2, 3, 4, and on, where x is greater than or equal to 70, but less than 100. So can you write me the roster method where x is a natural number, but it's greater than or equal to 70 and less than 100? My example looks like this. I knew that I could include 70, and I had to be greater than, so I did 70, 71, 72, and I was going to keep going, dot, 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 dot. And then where do I need to make sure that I end? 99, right? Because I don't want to include 100 because I'm not less than or equal to it, I'm just less than. So the number right before it would be where I stopped at 99. So maybe something that looks like that. Remember, order doesn't matter, so maybe you did it in a different order, but you should have started with 70 and ended with 99, or started with 99 and ended with 70. Either way, just make sure that all of your elements are correct there. All right, the next thing we're going to talk about here is what we call cardinality of a set. The number of elements in a set is what we call the cardinal number, or cardinality. So if I ask you how many numbers are in a set, instead of saying that, I could say, what's the cardinality of this set? Another notation that we have to be comfortable with is how to write cardinality. So this is the notation for cardinality. How many numbers are in set A? So for this example, if this is set A, then I have 1, 2, 3 different elements. I would say that the cardinality, using that notation, is 3. There are 3 elements in that set. Or if this is set B has 1, 2, 3 different elements. Even though it looks like there's more, there's really just 3 different elements. So the cardinality of set B, written like this, would also be 3. So even though it looks like it has more, it still has just 3 different elements. Its cardinality is 3. Make sure you know what that little notation means for later on. Let's look at an example of cardinality. Example number 8 says, find the cardinal number for each of the following sets. So I have set A that includes 7, 9, 11, and 13. If I was using proper notation, if it asked me for cardinal number or cardinality, I would use this notation, N of A. How many elements are in set A? How many different elements are in set A? I'd say 4. There's 4 different elements in set A. All right, looking at set B, the cardinality of set B, well, how many different elements are in set B? Did you say 1? Because there is an element there. 0 is an element, 0 is a number. There's 1 different element in that set. So his cardinality is 1. All right, look at set C. What's the cardinality or cardinal number of set C? Well, I have 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Did you say the cardinal number there was 11? I even used my fingers if I needed to. So the cardinal number of set C is 11. All right, what's the cardinal number of this set? Well, do you remember what this notation means? Well, this notation means that I have an empty set, right? So if I have an empty set, how many elements are in that set? 0, right? So the cardinal number of an empty set would actually be 0. Now be careful, don't put a little slash through your 0 because that means literally nothing. There is 0 elements in this set. So I need to make sure that I use the number 0 and not an empty set. Okay? All right. Make sure you practice that new notation, cardinal number, cardinality, and inequalities, and then we'll move on to our last video and our last few examples in section 2.1. I hope you're doing okay.